Welcome to part 1 of Competency 18. For this competency, the teacher needs to understand mathematical reasoning and problem solving. This competency is in Domain 5, which is 10% of your overall score. In this video, we will discuss indirect and direct proofs. Okay, before we begin, we need to show your or talk through this graphic. Okay, we have direct reasoning, indirect reasoning. Actually, let's just narrow it down. It's an indirect proof. Over here's your indirect, then we have a direct. What does it mean to be a direct proof? Start with a true hypothesis. Say whatever the question is, whatever they want you to prove, it's true. Then you end up with a true, showing that hypothesis, that what they said was true, but in between those two things, you're going to have a lot going on. Okay. You have to have calculations, proven theorems, things like that. So let's go to the indirect. Indirect is the opposite. You are going to assume that the conclusion is opposite, false. You can't just say this is false necessarily. You've got to look for what would be when it would be false. Okay, so, and then through that and some calculation, it is going to show that, hey, that's a contradiction in terms. That just can't be, or that's not what we assumed. So then this has to be uh we have to go and look at something else. We have to start over. This cannot be true. So, okay. And let me show you some examples. This is number one is classic. And really, I did not enjoy this the first time I worked through this proof, but I'm going to spare you that. Let's just look at the appropriate steps. Okay. Number one, select the appropriate explanation below that describes an indirect proof showing the square root of 3 is irrational. Okay, we got some things going on here. I hope you know. Here, let me get my pen to work. Okay, there it is. I hope you know what irrational means. Okay, irrational means that you are going to have um, a decimal, with a dot, 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 meaning it goes on forever. It does not repeat. It doesn't terminate. It does not repeat. Meaning, for example, you guys know you were taught in school that pi just goes on. That number value, it isn't 3.14. It is 3.14 dot, 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 dot. We don't know where pi can end. We haven't figured that out yet. Somebody will someday, I'm sure. Maybe. I don't know. Maybe it never ends. Who knows? We don't know. Okay, that being said, now that means that, okay, just to make yourself feel better, if you're not used to these things, if you don't work with these things, bear with me for everyone who knows the answer to this. Go ahead and put 3 into the calculator and enter it. Okay. Notice you get this long decimal. Prove to yourself there is no equivalent fraction. A fraction is rational by putting second enter. Remember, we did that before in other videos. See how it pops up again? So that's what you need to do. What is opposite? Let me get, first off, let's erase this and let's start highlighting so we don't have our stuff up. Okay. And let's make this nice and big. Okay. We want to, they say it is, our conclusion should be, is irrational. So we want to do the opposite. Remember, it's saying indirect proof, indirect reasoning. Okay. So this one is stating the same thing. See this? A won't work. Can't do that because of this. They're repeating what our conclusion is supposed to be. Okay, another one does this down here. Can't use that. Okay. All right, now let's look at this. Show a counter example that shows a contradiction. Okay, there's a problem with that. By definition, a counter example of this being irrational, is there a counter example? There isn't. And not only that, if you want to show a counter example, and let's begin looking at this down here. If you want to show a counter example, it says show a counter example that shows a contradiction. Then set the square root of 3 equal to the counter example. Well, what counterexample? And what I don't know that there is a counterexample, and there could be multiple counterexamples. You don't know. And which counterexample? If there was a counterexample out there, then you would know that there's some fraction. We just used our calculator over here, putting it in, and there's no counterexample. I mean, this D doesn't make sense to me. I mean, logically, I just can't flow with that. Let's just go with that. Hopefully, you guys can't either. Okay, let's go back to what we're doing. We eliminated that one. We eliminated that one. Let's go back to B. Okay, that's okay. Oh, look. We eliminated this one too. I forgot to mark it because it's saying the same thing as what we have up here. So I'm going to say maybe B. Now, what is it? Assume that it's false. Okay, the opposite, whatever it's supposed to be. Then show a contradiction. Okay, then it should say this shows a contradiction. Then show, yes, that'd be the next step. Then show that this irrational number leads to a contradiction. Yes. So let's get rid of that question mark. This is true. That's very basic. You probably would get a question that would be a little more in depth. Okay. Number 2, the following diagram, in the following diagram, the measure of angle 1, and the measure of angle 2 are supplementary to each other. Prove that line 1 and line 2 cannot intersect. Okay, we kind of need to know some basic definitions here, but I'll be honest with you, let's look at what the classic proof is. There's two ways to prove this. Either we prove, we prove this by showing that we say they aren't intersecting, means we're saying, hey, these are parallel, and they are parallel because this, and this. Now, that's that verifies our proof, our conclusion. What's our conclusion? This is our conclusion. So we start by assuming this is true, and then we just show, hey, that is true. Here's our calculations. We go through everything and we end up verifying. Or we say, hey, let's show the other. Let's show that it does intersect. And then let's show you the contradiction. Okay? Very confusing logical. Now, we won't need to, we won't need to show anything on our TI-84 for this one. We will on others, but not on this one, I don't think. Maybe. Okay, so let's take a look. Okay, if we show by contradiction, we're saying the opposite. So assume that line 1 and 2 are parallel and intersect at B. So what are they saying over there? They're saying that you draw line line A. If I could talk, that'd be great. All right. It's a classic proof. Okay. I see where they're going here. And this is going to create a triangle. And this triangle with those two measures shows this. How do we know that? That's going by the given. Okay. But what we're saying is, hey, by the given, those two angles are, so then this is a contradiction. A triangle should be 180. So if we draw a triangle where it intersects down there, then that's not going to work. Then since these are supplementary, then this means that angle A would be 0. This is a contradiction since the angles of any triangle must be greater than 0. Okay, I'm going to agree with all that. But let's see how the others begin. Well, this one, since the measure of angle 1 and angle 2 equals 0. So they're starting with the given. Then they're parallel with the, okay, they're making unsubstantiated claims. There's more to this. That doesn't just guarantee, that's a whole other proof. So if you know anything about these proofs, if you've done any of this work, which you should have by now in your coursework, this is missing stuff. I disagree. Now, this one says, assume that they are parallel. Okay, that's an assumption you can make. I am okay. Then, let's say measure 1 and 8 are 90. Oh, seriously. That's just plain wrong. They just want to catch and see if you know what supplementary means. No, that's complementary. So, can we say plain old wrong? Trick question. Okay, that's just wrong. Okay, now D. Assume that line 1 and 2 do not intersect. Okay, that is starting with the conclusion. Given that uh, the measure 1 and the measure 2 are supplementary. Okay, that is in the given. Then we have this. Okay, I agree with everything so far. This shows our conclusion. Okay, you can't do that. You just can't jump to the conclusion because you have a given. You got to add, there's more. Where's the more? There's more to this if you've done this before. So I'm going to have to disagree with that, and let's go with A. And A is what they've described there is, I mean, they could have put a little more detail in there, but that gets down to the nitty-gritty and it is classic. So if you see something classic like that and then the others just don't make sense, go with your gut. Okay, number 3. In the following diagram, EG is perpendicular to the line, this is a line DF. Prove that the measure of DEH is greater than 90 degrees. Okay, so let's just highlight this is what we're talking about. Okay, now the fact that this is perpendicular, okay, what does that give us? That gives us that 90 degrees right here, okay? This. All right. So we can use some of these things to help with a proof. Okay. And yes, it is a classic problem. And yes, generally we start by contradiction. Now, if you come across an answer choice that does not start by contradiction, follow it through just in case. Just double check what they give you. Okay. And make sure it makes sense. All right. So, what are they going to do? They're going to start with a contradiction, and a contradiction would either be less than or equal to. Don't forget the equal to. You be equal. Okay. All right. So, assume that the measure of DEH is less than or equal to 90 degrees. I agree with that. By the addition rule of adjacent angles, the measure of DEH equals the measure of angle DEG plus GEH. Now, looking at that, yes, I'll leave that right there. Yes, I totally agree. That is true. All true statements. Since it is given that they're perpendicular, yes, they are perpendicular, then the measure of DEG equals 90. We've already said that. So the measure of DEH, okay, that's our total angle, is 90 plus the smaller, see, GEH, double check that. And they are added together, double check, which implies that the measure of angle GEH, that's the smaller one, this smaller right here, this right here, okay, equals the measure of the angle we're looking at minus 90. Okay, but this is a contradiction, okay? Since the measure must, okay, this is a contradiction since the angle measure must be a positive measure. So what's really going on? They're saying that DEH is smaller. If we take out 90 degrees, then we're going to have, it implies like that you could have a negative value or a zero. And well, maybe, but I agree that this contradiction idea, I agree with everything. It's very classic. It looks exactly what I've seen before. It could have more detail, but it's correct. So I'm going to go with that. So now let's look at some of the other things. And as we go, we're going to point out and be careful that some things may be incorrect. Okay. Assume that it is less. Okay. I'm not going to say anything on that because that's okay. Since it is given that it's parallel, then that equals, double check the name. Yes, that is true. By the addition rule, then DEF, oh, that doesn't, okay, well, DEF equals, okay, that doesn't make sense. They're saying DEF equals a measure of DEG plus Oh, actually, that is a true statement. That's saying the entire line. They're taught DEF. Where is that? This DEF, that's the line. That equals 180. So then the measure of DEH equals 90 plus. Okay, none of that makes sense. They're saying you have the line, and because you have the line, DEF, yeah, that makes no sense. You have the measure line, then this applies that 90 plus. Yeah. Okay. That would mean that the way they have it, that this larger one is 90. So what this says is it equals 90. That makes no sense. So that one's out. Okay, so let's look at C. Assume that the measure of DEH is greater, okay, and then we have the addition rule, and we are saying the same thing, and we're saying that DEH, which is one we have, is DEG plus, okay, GEH, okay, so all that's true so far, and this is given, yes, yes. And then they're saying that DEH equals 90 degrees minus the measure of GEH. That doesn't make sense. Or does it? DEH minus, well, yeah, no, it does make sense. If we have DEH and we have equals 90 degrees minus, okay, it does equal that. My problem is, where's the rest? It's missing a big chunk. Where's the rest? Question mark. There's more. Doesn't make sense. You can't just jump like that. You have to show why you can subtract that angle from 90. Yeah, doesn't it implies that mm, and this implication, no. I I can't go with that at all. Assume that the measure of DEH is greater. So, okay, this is true. This is true. This is true by the addition rule of adjacent angles, the measure of DEF. Okay, DEF. Okay, that's the whole line. Equals DEG plus, yes, that's true, but what does that get us? Then the measure of DEH equals 90 degrees plus GEF. Okay. So what it's saying is that that doesn't make sense because the line is 180. And then we're going to say that because DEG is 90, that this is DEG plus GEF. Well, if that's true, GEF has to be 90. So then we're saying what that's saying is that DEH equals 180, 180 degrees. Yes, that is greater than 90, but it doesn't make sense, which implies that. And then this GEF is okay. Well, that's all true, but it doesn't help us. What it's saying is that DEH equals 90, 90 degree. I mean, 180 degrees, which leads to a strange conclusion that doesn't show what we need exactly. That's an inappropriate proof. Okay, we've gotten with A. Yes, these are difficult. Notice I didn't even go to my calculator one time. So confusing. All right, let's go to the next one. Okay, please note again that I already can tell you that for number 4, we will not be using our calculator. I know that we are focusing on the use of the TI-84. However, for some of your tests, not a lot, but for sections of your test, a calculator is not required. You just simply have to know some of these things. Okay, in the following diagram, triangle ABC is scalene and the segment AD is perpendicular to BC. And when something is perpendicular, we know that we have a 90-degree situation. All right. So you could try this indirectly to prove this. There's more than one way. Okay, but let's assume. Okay, and it says prove. Sorry, it'd help if I'd read the rest of it. Prove that BD, that's this right here, is not equal to this DC. Those two segments are not equal. Just because we have a picture and we have a visual doesn't mean that we can just say that, okay? We have to come up with some kind of a proof. All right, what I want to do for this example is let's look at the classic way to do it by contradiction, okay, which is the best way to do this. Or counterexample, if you've taken courses, you understand what that means. So, if you don't understand some of the things I'm saying, please go to the internet and find yourself some good sources or go back to your old textbooks. Okay, so if we're going to do this by saying that from our diagram, this is what we want to be true. So let's first say it's false. Okay, if we do that, we can't use this one and we can't use that one. This gives us the last two to evaluate. Now, if we state the opposite or the false, okay, then our proof that we're trying to select must say at the end that they have a contradiction. So let's check that. This is a contradiction. because it's scaling? Yes. Okay, this is a contradiction. Yes, so they both have the same thing. So I agree with both those. If you don't know what scaling is, scaling means uh, that none of the sides are equal. So we have three different unequal sides. Okay, and actually for this one, I know you could prove that all of those segments that make up the large triangle and the two smaller ones are not the same. But we'll move on. Okay. All right, let's go to C. Assume that, okay, BD and DC are equal. Since AD and BC are parallel, then yes. So yes and yes. Okay. And that AD equals DA by the identity postulate. Yes, that's a postulate from Euclidean geometry that you should know. It's just meaning that if we split these into two smaller triangles, that this AD down the center, if we redrew them, they would be congruent. And then we could show some similarity. Okay, let's see where that's going. Then, yes, and that's what they did here. ADB is uh, congruent to ADC. Okay, here's the thing. Yes, you could say that. You could even say that they were similar. Actually, that's the truth. They're not congruent. They're similar, but they're saying they're similar by the angle, side angle. Make sure you remember what all those mean, which implies that A, B, let me get another highlighter. Okay, that AB is congruent highlight to AC. Okay, since corresponding parts of congruent triangles are congruent, and that's another way to prove things. It's a theorem. This is a contradiction since it's scaling. The fact that we said it was scaling in the given says that's a contradiction. I absolutely love C. What do I not like about D then? Okay, everything looks to be the same, but they left an important fact out leading to this. So when you compare the two, you see it's left out. So I'm going to say I don't like D and I will go with C. Unfortunately, you really do need to refresh your stuff on some of these things. It's not something that we can prove in our calculator. Okay. The same thing is going to apply for number 5. There is no calculator use unless you put the values of 3, 4, 5 in as we go. I'll talk about it in a second. You could put number values on this and kind of help yourself to prove it to yourself. But again, this is a situation where your TI-84 is not going to be very helpful. You need to know these concepts. That's kind of why I left them in. Could it kind of prove to you that your calculator doesn't do everything for you? Sometimes just plain studying is what we have to do. Number 5, in the following diagram, GF is a chord of circle E, but it does not contain the center of the circle. Okay, what does that mean? That means the center is E. So there is no E right here. See, there is no E. You have no center midpoint that includes this. What they're trying to say is, hey, if it doesn't have the center, it cannot be the diameter. They're trying to say in the given, this is not the diameter, which is a important point. What would be the step what would the steps be to prove that GF is less than the length of the diameter? Okay, in blue is the actual question. The only way you can answer this question is to know some facts, okay? And in our options down here, you'll see some of those facts. Okay, first thing up, okay? The image is a redrawing. So what you have to do, if you're allowed to write on your test, I think you are. I don't remember at this point, it's been too long. Okay, you draw this inscribed through the diameter. So you know that this right here, this diameter with this E, okay, let's think about this. You know that's half the circle. A diameter dissects, bisects two equal halves of the circle. So you know the arc length. Let me do a little highlighting. You know this arc length right here. That guy right there is equal 180. If this guy equals 180, then the created opposite angle that I've colored in right here, you know he has to be 90 degrees. That's just something we already know and we've built it. Okay. So if we look at this, that fact, so what is that fact? That the arc length created by our line creates the angle at the other end for the 180, that's angle G. That's half. So this is going to be true of the others. So the arc FG creates an angle of H. This arc creates that H angle will be half. So H is 1/2 of FG. And if you look at that, then we're going to have to go in order because we know the properties of this right triangle. We know the concept of the two legs equal the hypotenuse. Okay, there's a couple ways you could go about this, but again, the classic way to do this is by contradiction. Okay, and the contradiction would be, okay, we want that DF is less than our diameter, and our diameter is equal to the, what are they calling it here? No, not, it's FH. Okay, well, the first thing we need to do is I already looked down here. You probably are looking at my options and saying, something's not right. A won't work because we are trying to say that GF, it says less than FH, and the opposite would be equal. This one's got the wrong letter, so that won't work. Let's check our letters. This one, it's the opposite. Yes, that's stating, okay, whoa. And this one is saying it's not less, it's greater, but it has the correct letter, so I'm going to be okay with that. Let's look at D. D has the incorrect letters. That won't work. So let's get rid of that. So now we're down to these two. What do we want to point out on these two? Well, we know that at the end of our steps, we need to have a conclusion. Not a conclusion that's a contradiction. A conclusion that is a contradiction. Yes, I agree with that. So in between, we have to read and see if we find anything that trips them up, shows something incorrect. So let's look at B. Assume that, okay, we already said that's true. Then show that the measure of angle, okay, which we talked about, H, is greater than, okay, all right, we could show that. Since the measure of the inscribed is 1/2, okay, the measure of its intersecting arc. Thus, H is greater than G, which implies that the angle FG, not angle, the arc measure, that's what that little hat is there. That means the arc measure is greater than FA. Okay, that's the whole half. Yes, but that leads to contradiction. So what they're saying is we go through, they probably left out some stuff. Okay, I'll buy that. Let's look at the next one. Because everything they're saying is basically true. If it's equal, if we're saying it's equal, then we could go with one being greater than the other, even though we disagree with it in the image. Okay. All right. We're trying to show this, okay, as a contradiction. Okay, now assume that, okay, well, the lettering is correct, and you can assume anything you want in most cases. Then show that the measure of H is less than G. But that's not a contradiction. That won't lead to a contradiction. And, well, yeah, it would, because that's just wrong. You would have trouble showing that, because what you're trying to say is show that it's smaller with this fact right here, and that wait a minute, look, your statements are contradictions, and this cannot be proved with that. So this whole thing would just be considered a wrong proof. So we have to go with B. Okay. All right. And that is the end of our questions. I want to thank you for watching. And sorry that we didn't use any TI-84. Just one way from you showing you that, yes, the TI-84 is helpful in over 95% of any given test like this. However, sometimes your knowledge is worth its own weight in gold also. Okay? And if you like us, give us a thumbs up and consider subscribing. We will have more of these coming out in the future. Thank you.